Okay, so next we are going to look at the electric motor installation. Okay, so we have you can check out our training on installation resistance testing. Okay, we have that training also, so you can check that. So but the installation, what we are actually looking at is the stator windings. Are we getting it? So the installation between each of these phases. Remember we said the windings, they are wound into 3-phase beds. Okay, so those phase beds, they are separated by lead rods. Just check out our training on installation resistance testing on electric motor. So we test the insulation separating these phases, and then the insulation separating the phase and ground. So what we'll do is that we have the insulation tester, Omega insulation resistance meter. Then we have one of the probe on the each of these phases. Okay, since you have it dated like this, it means that all of the windings, they are connected together. So if you have one probe here and one probe on the frame, that will give us the insulation between that is the body, that is the ground, and the windings. Okay, so if we remove those bars, we can test the insulation between the U phase, the V phase, and the W phase. Are we getting a U, V, V, W, and W, U? Okay, so usually we expect the insulation to be high. If we are looking at low voltage electric motor, 10 meg is okay. Okay, but if we are looking at medium and high voltage electric motor, 100 meg is okay. But even at the low voltage electric motor, we need something to be, we need the insulation resistance to be very high. The higher the insulation resistance, the better for us. Okay, so the insulation fault zone is another area that we need to look at, because a failing insulation will affect the reliability of the entire electric motor system. Okay, then we also want to look at the rotor fault zone. Remember, as we discussed earlier in this section, the rotor, the feed generated in the rotor, interacts with the feed generated in the stator. So anything that affects that feed, what will happen is that they affect that interaction. What happens is that the efficiency of the electric motor will be affected. Okay, so that is what we actually do here. Okay, we use the Mega Tester MTR105. Okay, the MTR105 can actually assist us in doing this, because we check the inductance, okay, the rotor influence, how the rotor changes in the rotor direction, position, I mean to say, affects the inductance of the stator winding. Are we getting it? So as we take that reading, as we rotate, we take the reading, we'll see the rotor influence on that inductance. Okay, so when there are problems, especially when residual flux or magnetic field in the rotor is more than what is normal, okay, we'll see it during that rotor influence test. So in doing that test, it's just to take this the selector switch to this inductance, capacitance, and resistance test selection. Okay, fix your probe appropriately at the top, and then you conduct the test on the electric motor. Okay, you can also do inductance unbalance test. Are you getting it? Although that will give you an idea of the stator winding, okay, resistance. So that is tells you the integrity of the stator winding. okay, as we'll see much more later. So the next is the power circuit. The power circuit is also another fault zone. So like we said earlier, the power circuit is from the beginning of the feeder line to the termination on your electric motor. So anything that affects this power circuit will affect the reliability of the entire motor system. Okay, so what we do on the power circuit is that we do low resistance testing. We use the milliohm meter. Are we getting it? To test if there are resistance build up. We know that if there are resistance build up along any of these lines, what will happen is that it can cause voltage unbalance. And as we saw earlier, that voltage unbalance have the effect of increasing the current that is flowing through the system, and thus the heat that is dissipated in our electric motor. So how we do it is that once you have the motor connected like this, okay, you can test between, once you have this circuit breaker open, okay, your contactor closed, or you can come to the contactor end, because basically all of these two, they are closed in the MCC. Then from here to here, they are the cable supplying from here that runs from the MCC to the feed where we have the electric motor. So these ones are longer. These are very short runs. Okay, so we can do our test here even when the contactor is open. Okay, so we can run our test here. So when you run your low resistance test between line 1, okay, between line 1 and line 2, what you'll be doing, if assuming we have a star connection, that is, you are testing the resistance of this conductor, okay, through one winding in the stator coil, okay, and then through another winding, that is the second phase winding, then this yellow conductor to this point. Are we getting it? So which means that whichever point, if it is line 1, line 2, we take, line 2, line 3 we take, or line 2, line 1, line 3, and line 2, line 3 we take, you see that since we are looking at the same length of cable, the same resistances, that is the same winding, that two winding in each readings, okay, we expect that the resistance reading should be the same. Are we getting it? So again, we look at the unbalance here. Remember, we also look at the average, subtract each of these resistances from the average, the maximum deviation, as we said earlier, when we are looking at the voltage unbalance, we divide it with this average, okay, to give us the percentage unbalance. Are we getting it? So we're also looking at the same level between 0.5 and 2.5 is okay, but once it is higher than, it means that something is wrong, okay, and that could mean that either any of these lines, they have high resistance connections, or within the electric motor itself, the windings may be shorted, or it has high resistance connection at their various connection points, either at the terminal block or within the windings where we solder the coils or the windings together. That could be the reason why we have this unbalance. So you need to check to ascertain which area in the circuitry is actually causing this unbalance. Remember, we tested from here to, we started the test at the MCC. So what will happen is that you can disconnect, go to the motor in the feed, disconnect these 3 terminals, test the winding resistances. Okay, so if the winding, the resistance unbalance is not up to what you have, it means that the unbalance is generated along or is created along these lines. So it could be that we have joints on these cables that are already failing, that are not properly made. Okay, so those joints, we can go and refix those joints so that we can improve or reduce the resistances of those joints. But if the unbalance is coming from within the electric motor, we need to check further, can do the winding inductance test to ascertain the level of unbalance in the inductance. Remember, the inductance will give us a better value than the resistance, low resistance meter, simply because the inductance in relationship with the resistance have a linear relationship or a direct relationship with the number of turns. Are we getting it? Why the inductance have an exponential relationship, n square. Okay, so that will give us a better idea of what is happening within the power circuit. Okay, so that is how we check the power circuit, but of course we will not neglect this part too. We will check to see if we have any high resistance points on any of these parts. And of course, we will also check the integrity or the reliability of the control system to see that it will also function as we intended it to function. So the air gap, as we talked earlier, we use the MTR 105 mega to test the rotor influence, okay, on the stator magnetic field. So the stator itself, like we also said earlier, we have the windings, okay, so we can do the low resistance tests on each of these windings, or we can do the inductance tests. Are we getting it? To see if there are any unbalance. Okay, remember, unbalance in the resistance will affect the voltage, can also introduce voltage unbalance that will eventually affect the operations of the electric motor. So that is what we will do. You can check out our training on resistance tests and also low resistance winding resistance tests, okay, on electric motor in our earlier section. So the MTR2 can do it. So you see the milliohm selection. You can turn this your selector switch to the milliohm, connect your probe appropriately, then you can test, okay, and do your calculations to see if we have any resistance on balance. Okay,